Hello. Well, it's great to be here. I just want to say hello to everybody, and I'll defer the goodbye now because we don't know how it's going to end, and I want to make sure that I get that out of the way. It's an honor to be here, and thank you everyone who's chosen to come and spend some time with me, given that Dave Cheney's speaking at the same time in another room. I said, "What? Sit! It's too late. Sit down." So, I've been doing Go for a long time, and I really love it, And most of that time has been spent writing HTTP services, and I've sort of changed things as I go along across the years, and some things have really stood the test of time, and these are the things that make it into this presentation. I do the Go Time podcast, so you can listen live on Tuesdays. Put that in your ears. And I've got a book and blah blah blah. So I'm gonna crack on. So last year I wrote this blog post, and by the way, you should write blog posts. I really recommend it. You don't fall into the trap of no one cares what I think. It's not true. So please do write blog posts. In fact, I wrote my first ever blog post, and I got a book deal from it. And I'm not saying everyone's going to get a book deal, although packed. But please, share your experiences, because we are interested in them, even if you feel like no one would be. So this blog post went a bit viral. It got 150,000 hits, which for me, that's massive. I mean, obviously, Jessie Frizzell tweets, dropped a bagel. She gets that many likes. But for me, this was big. And I was interested in why that was, and that's why I'm bringing it on tour, the blog post. It was also I've gone too far. It was also the most clicked link in the Go Weekly newsletter in 2018. And check this out. Look what they say. Amazingly, do you know what I mean? Like, thanks. What do you mean amazing? Trolling me on it. Meant to have won something. No. But I know what they mean. There were lots of more interesting and deep technical blog posts, some very beautiful ones, some very brilliantly written things. But at the end of the day, we do have a job to do. And so sometimes just very practical things are interesting and useful. And so I think that's what this is. Someone put it on Reddit, and I didn't realize this, but you actually can type nice things into Reddit now. I don't know when they added that, but so I got some criticism, some questions, some comments, some ideas, and I've really sort of taken all of that and folded it into this. So it's not really all coming from me. I also more or less exclusively pair program at the moment with David Hernandez. And a lot of these patterns we've kind of figured out together as well. So it's not just my thinking here. It's really been influenced by the whole community. And so it really belongs to everyone, I guess. So how should you use this talk then? I think this applies to every talk. It's not meant to just be taken literally. It's not a rule book that you have to follow. It's not scripture. They're valuable things because, as I said, they've stood the test of time. So there is something useful about that. But a lot of this depends on your context as well. And you might be operating in a different context, and you might have great reasons to do things differently. So absolutely, you should do that. It's really, I'm going to try and focus where I can on the philosophy behind some of the thinking rather than the literal little code snippets and stuff, although hopefully that's all useful too. Software is about trade-offs, and it's not a right or wrong. So if you do disagree with things or you prefer doing things a different way, absolutely, totally fine. And I also recommend, if you can, try things out for yourself in your team. If you're a manager or a tech lead, or you're responsible in some way for the time of the team, build in some buffer. Let the team explore these ideas and explore different ideas. It pays dividends. It's really valuable, and it's not a waste of time. So please do that. So when I selected these items that I'm going to talk about, and really how I come up with and how we end up in this situation, I think, is driven by a few sort of philosophical points. And I just want to highlight them now, and then we can, and I'll point them out throughout as well. So the first one is maintainability. Maintainability doesn't get enough attention, I don't think. We spend a lot of time obsessed with how long is it going to take to build in the first place for us to then deploy, right? Which makes sense, because then customers can use it. But there's a cost to maintaining code, and sometimes it's worth doing things differently if it means you get better maintainability. Sometimes it's worth taking a bit more time on something if it means the maintainability is going to be easier. So yes, maintaining code, in some contexts, that cost of maintaining can be bigger than the initial cost of actually deploying it in the first place. So it's definitely something to bear in mind. Glanceability also, I like talking about this one. The idea is how quickly, from just glancing at some code, how quickly can you understand more or less what's going on? You know, we kind of, I think we have landscape kind of navigation software in our brains from our early evolution, which I think we use when we're thinking and mapping out our projects. I don't know, but I'm not a scientist. I mean, a computer scientist, I suppose. But so yes, I think glanceability is important. How quickly can we figure out where we need to go to do things? And so sometimes decisions are made that improves glanceability. I think code should just be boring. As programmers, we want to be creative all the time, and we want to find cool, creative ways of doing everything. But actually, I don't think we need to do that in our code. The code should be boring and obvious, because then it's more maintainable, it has better glanceability, and more people can use it. And you think about this conference, how big it's growing and how Go is growing in general. There's a lot of new people around. And so we want to make it as easy as possible for those new people, whether from other programming languages or if Go's their first programming language. You know, we want to make sure that they can take part as quickly as possible. So sometimes decisions are made in that vein too. And also self-similar, being consistent. Consistency and self-similarity helps with all of this too. So sometimes I will have a pattern that I use, and it might be a little bit over-engineered for this particular case, but in the wider context, it might just be similar enough to other things that it's worth doing for its own sake. So there's some code in this talk, and I just want to highlight a couple of bits. I use this little is framework for doing assertions. It's like testify, but tiny. Testify is enormous, and is the opposite. It's tiny. It's like testify off steroids. That's what is. There's a comma there. The source code is, in some cases, more illustrative, but I did try and make it all real. So hopefully it doesn't look too weird. I want to try and make it look as real as possible. And I mostly use the standard library. Although I'm not a standard library fundamentalist, I'm more than happy to use code that other people have written and really see the value in that. And Julie Q has a great talk on how to pick those dependencies and what you can look for to make sure you're being wise in your choices of what you bring in. And with that, it's code time. So let's get in. Let's get stuck in. Okay. So the first one, this actually applies to anything I'm writing, not specifically HTTP services. But I do this tiny abstraction from main. I really like being able to return errors as things, if they go wrong. And you can't do that in main. You know, sometimes you might have code which is going to do something like this, where you're going to print to standard error and then exit. If you had a lot of things being set up in that main block, you're going to have to repeat that lots of times. So this is a very simple way of allowing yourself to just return error. So it's very simple. I stole this from Francesc Campoy. I have a server struct. So I have a type which kind of represents the component, and the dependencies go into that type. So I like this because it makes it pretty clear what this server needs in order to do its job. And also, it removes the temptation to have these in some kind of global state. So you instead of having this just as a var in the package space, these dependencies, you have them in the server, and it makes a whole raft of things a lot easier. Peter Borgen said this. If he had 5 words, he would just use 4 of them, that's very Peter, very efficient. Yeah, but he's right. So he says if you don't use global variables and you don't have this global state, then you cut out a whole class of potential errors and bugs and difficulties when testing and things like this. So having the server struct is nice because you keep that all nicely contained. I like to avoid constructors generally because really you don't know what's happening. If you call a constructor without looking at the code, it could be spinning up Go routines, it could be allocating all kinds of memory. Whereas if it's just a type, if you're instantiating that yourself, then you know exactly what's happening. So there's a kind of very clear, expressive readability advantage to not having a constructor, but I always end up with one. So, and it's essentially, in here I just create the instance of it, and I set up the roots. So I do the work that I have to do every time. But notice I don't set up dependencies here. I don't connect to a database, and I don't sort the logger out and do all these other things, because I want to use this server and this constructor in different ways. So if you have a couple of dependencies, you can pass them in as arguments here. That's okay too. But usually you end up with quite a few, and I don't really I refuse to call a method if it has 4 arguments or more. I don't really refuse to do it, obviously. I don't have a choice if I need to call that method. So, but it defeats the object a little bit of having that server struct, right? We want that server struct to list out the dependencies. We don't want a big function that has all those arguments in there. You can make server an HTTP handler. Anybody that hasn't seen or read about HTTP handler and HTTP handler func, I recommend checking it out. But essentially, HTTP handler is an interface, and you just have to implement this one method. And that's everything you need in order to deal with web in Go. Notice it has a HTTP response writer and an HTTP request. So that's your request and your response. That's how you interact with the outside world in Go. So if you put this method on it, it means it becomes an HTTP handler. So then you can just use your server. But notice all I'm doing in this example is passing execution to the router. I'm not doing other logic in here. And that's important because it would be a strange place to have other kind of logic. So if you do have, if you want to do logging or tracing or things like that, it's better to use middleware or something that's explicit rather than sort of hide it inside this, because I wouldn't think to go and look here. It would be the last place I look, probably. I always have a roots.go file. So generally the advice in Go is to group things up by responsibility. So you could have comments in a file, and everything you need for comments is there, and you could have people in another file, and everything you need for people is in there. And I think initially I used to do routing in each of those places too. But having a single file that maps out your services like this is extremely useful. And if you think about any time someone's mentioned a bug or asked for a feature or asked for a change, you usually get a URL. When it's an HTTP web service, that's kind of what always comes in. So then you need to be able to just go and find the handler that's dealing with that request. This is a very easy way to do this. And it's very glanceable. You can see the whole map of your API in one place. So I think that's a real kind of advantage when it comes to maintainability as well. My handlers hang off the server like this as methods, and that's how they can access the dependencies inside the server. So it's kind of, it's just normal Go code, isn't it? It's just a method, and we sort of know how methods work, and so we don't have to use other ideas or other concepts in order to solve this problem when we just have methods. So it's nice because it's simple. Anybody that knows Go already knows probably how to do methods, and it's nice. You do have to be careful because it's worth remembering that every HTTP request that comes into your server gets its own Go routine. So you have to be careful about what you do with that server because you could have concurrent code running against it, and you want to avoid data races and things like that. I name handler methods like this despite how I used to do it. I like to be more expressive and say, for example, create task handler, because that's how I would say it in real life. And flipping it over actually gives a nice advantage that the IDEs will group these up, and the documentation, if it orders alphabetically, it groups these things up by responsibility. It's very useful. So that's a pretty simple little tip. It works in other cases too. And I quite like it. It's very handy when you want to actually start to find these and look for them. It's sort of really easy to find where you need to be. So I actually return the handler rather than the method being the handler itself. If the method was the handler itself, it would take the response writer and the request in. It doesn't. It instead returns this HTTP handler func. And that's just an anonymous function that you return after calling the method. And what that gives you, it's a slight indirection. So, I usually would prefer things to be I would just have the handlers as normal handlers. But the advantage to this is you get a little closured environment where you can do some cool things, including setting things up. For example, we have this thing. So we prepare a thing. You can do some work to get your handler's dependencies ready if they're handler specific. And of course, you can use that thing inside the anonymous function, and that's how you can access it. Remember, data races also applies here. You do have to pay attention to that. If you have any specific dependencies for a couple of handlers, then maybe you don't want to put them in the server type. You can have them as arguments on this handler method instead. And then you can access this, in this case, the format, you can access that inside the body, inside the little handler function. Again, it makes it very easy to see what this handler needs to do its job. And in fact, because of the type safety and things we get with Go, you can't get the handler if you don't provide the dependencies. The compiler won't let you do it. So it's just very useful. It's sort of no-brainer. And if you compare that to just having things in global space, then you don't really get any of that help. Here are some more examples of things you can do. For example, the handle random quote needs a quota and a random number generator. And Tim Raymond actually pointed out that in testing, you can create a random source with a predictable seed, and therefore you stop it being random and you make it deterministic, which is a nice side effect to having the random thing taken in as an argument. And again, more type safety and compile time checks, which we like. If your handlers grow too big and you end up with a server that has lots and lots and lots of things on it, then it kind of starts getting a bit messy and a bit noisy. So you can have multiple of these. You can create a server for people and a server for comments. And you can decide how you want to name them. If you've only got a couple of them, then the grouping thing's not necessarily that important. But what's nice is, again, you can list out the dependencies that each thing needs, and they don't have to be the same. So it's a great storytelling point of view and kind of allows people to discover at a glance what's going on. I always use now handler func over handler, actually. And if you look in the source code, you can actually see how this works. There's a handler interface that just has the serve HTTP method on it. Then there's a new type that is a function that happens to match the same signature, takes the response writer and the request. And then that function has a method on it, which is the serve HTTP method, and it just calls itself. So essentially what that means is, if you want to create a handler, you don't have to create a type in order to do it. You can just use an anonymous function and just cast it to HTTP handler func, like this. Now, sometimes you have to do some switching between handler funcs and handlers. That can happen a few times. And if you find yourself doing that too much, then maybe you just want to use handlers. If you're using third-party packages, most of the time sometimes they provide both, but most of the time they just implement the handler interface, and you have to then do some magic, do some switching, not magic, do some switching, casting and things, which it does look a bit messy, to be honest. So if you do find that's happening too much, maybe you need to switch over a little bit. But it's not too bad. So middleware are just Go functions. This has been talked about before. It's actually, I think, really nice because it's just normal Go code, but it turns out to be really powerful. So the idea here, for anybody that doesn't really know about middleware in Go, is you have a function, you pass in the handler, and then it returns a new handler that can then do different things. It can do things before calling the original handler. It can do things after calling the original handler. Or in this case, not call that original handler at all. For example, if the current user is not an admin, we just, in this case, say, oh, HTTP not found. We just pretend the root's not even there. If they are an admin, then it'll fall through, and the handler will get called, and then they can access that endpoint. So yeah, this is really nice. You can solve lots of problems with this too. There's you can use this for logging and tracing and things like that. You can do authentication things, very common. And what's nice is it's very explicit too. And notice that this is also a method on the server, and so therefore it can access the shared dependencies as well. And it also has its own little closured environment too. So you can do middleware specific setup if you need to, which is kind of cool. I wire these middleware up in the roots.go. And this is part of this idea of having a single place that has everything you need, that explains the API footprint of your service. So you can see very clearly there that this /admin root requires you to be an admin because it has the admin only wrapped there. And that's how you call the handlers too. That's how you call the middleware. We just call the method, pass in the handler. The one that gets returned is the one that then gets routed by the router. And there you go. It's all wired up nicely. So, dealing with data. How's it going so far? It's all right? Yeah, it's all right. Thanks. Mark Bates, ladies and gentlemen. If you needed any motivational speaking done, here's your man. Okay, dealing with data. So, before I get into this, actually, here's a thing that happens a lot. We all do this. We're all guilty of it. We abstract too early. As soon as we smell that this thing we're doing could be useful elsewhere, then we want to abstract it. We're obsessed with dry code, and we find any opportunity to not repeat things wherever we can. It's very natural, I think, it seems. But it's worth resisting. It's better, in my opinion, to solve that a few times yourself first, and then have a look and see if there's an abstraction that emerges from that, rather than trying to imagine it up front. However, I always find that this is useful, and essentially I have a common way of responding. So it's really a helper here, and it's just called respond. Pass in the writer, the request, the status code, and the data, and usually these helpers usually start very basic and very simple. And if you looked at this in isolation, you might think, I don't know, maybe just have the JSON code throughout. But of course, the advantage is if you want to change the data formats you support, you can do that in one place, and then all of the service gets the improvements. So for example, it's common to check the accept header from the request when deciding what to send back to the client. And it allows you to support different formats. And you can do that. You don't have to do it in the beginning. In fact, you probably shouldn't. But you can do it. It's easier if you've abstracted this a little bit here. I do the same for decoding as well. And you see this one. See, if I wrote this in a project, normally David and Anders would say, no, we're not. No, nope, no. That's how he is. That's my life. The nicest thing he ever said to me was, that's not a terrible idea. And I think Spanish is his first language. So I hope it's just a language thing, but his wife assures me, no. No. So this is the same thing. We're going to decode, and all we're doing is asking the JSON stuff to do its thing. But later, we could check the content type and do different things. So, we could support other formats, like not XML, but other formats. I don't know what other ones there are. Now, you can future-proof any helpers you write with this simple rule of always taking both the response writer and the request, even if you don't need them now. Because this is all you need to deal with HTTP in Go. So it's all you're ever going to need. And you can future-proof your helpers by taking these two arguments always, which is kind of cool. I love this. I absolutely love doing this. So here, I put the request and response types inside the little closured environment. It's very common to just have these in the package space, alongside the server type. But then everyone has to be uniquely named. You're going to clutter up the package space, so your documentation gets big, and maybe in the IDE, when you're typing, you type dot, and you see the little list of things. That's going to be massive if you have not even that many, a few different handlers. So doing this hides them instead inside this handler. So you know as well that they're only relevant here because they're not accessible outside. So again, you're storytelling here. And imagine if a junior developer or somebody new to Go comes along and they're asked, can you go and work on the greeter endpoint? Well, look, they go to roots.go, find the greet thing, go to the handler, go to this, and they have everything they need right there. So I find it to be great. I love that. Sometimes, if you're doing handler-specific setup in this way, sometimes it can be quite slow for your service to start up. Now, if you're running this in a situation where it spins up once and it just stays running forever, then maybe that's okay. But I deploy a lot to Google App Engine, standard environment, and there's other services that scale down to 0. And if they scale to 0, it means when the first request comes in, then it spins up an instance ready to go. And Go starts up very, very quickly. On App Engine, it's by far the fastest. In fact, you don't even notice from an experience point of view. You sort of hit the URL, and it's just there. It's as though it was always running, but it wasn't. But you can start to affect that if you're doing all of your handler setup every time. So we can use sync once instead to do this when this particular handler is first called, rather than when the program first starts up. And you do it like this. You have some variables in the little closured environment, and one of them is a sync once, and then you call sync once. You call the do method and pass in an anonymous function, and the sync package will guarantee that only gets called once. So remember, every HTTP request gets its own go routine. So you don't want to be. It's possible to have a few come in at the same time, and you've got to be careful that you don't get data races and create some other problems. So this is a lovely little way to do that. And it also has the added advantage of, if this handler never gets called, this setup's never done. So in those scale to zero situations, depending on your situation, that can be a big time saving and a big resource saver. Testing. Show of hands. Who writes tests? Okay. Does anyone write tests first? TDD. Much less. I can't see you at all. I was just pretending. I feel bad. I feel like I'm lying, so I'll just tell you. So testing. Okay. Yes. Testing is a great tool for maintainability, by the way. In fact, you need it. You need it. So there's a few helpful things I'm going to hopefully share here that will talk a little bit about testing HTTP servers, and I think, well, we'll see. Okay, so the first one is the HTTP test package. If you haven't seen this, you should definitely check it out. It's insanely useful. You can create HTTP requests with it, and unlike the http.newRequest function that can return an error, this one doesn't. So it makes writing tests easier. So you can create requests, you can create a response recorder by calling new recorder, and that is essentially, it implements the HTTP response writer interface, but it just stores all basically the response. So when you call write header to say, I'm going to respond with this status code, the recorder just keeps a little note of what status code was returned. It also catches the body. So if you write the body out, it catches it in a buffer, and you can just directly access the body and make assertions, make sure that the handler's returning what you expect it to return. And there's also a server type in there, which is extremely useful if you want to stub out third-party APIs, and I'll show an example of that too. But check this out, the docs, it's not a very big package, but it's insanely useful. So our server that we've made is very testable because it's just a function. So we call the new server, and you can see here that I'm also then going to set up a test database in this case. You might choose to stub it out or mock it. Depends on your testing strategy. But the point here is this is very quick. All it's doing is creating the server and setting up the routes. It's not doing all the setup if you've got that elsewhere. If you've done it inside the sync once, or you're doing it inside the anonymous function instead. So you cut out everything that's kind of expensive, and that means your tests run really quickly. And that's what you want. You want your tests, unit tests in particular, should just run very fast because you want to run them all the time. And the advantage to that is you sort of get this live feedback from your code as you're going. So it's insanely useful. And then now look, I'm using the HTTP test package here to create a request, create a recorder, and then I just ask the server to serve this request. And it's kind of simulating a real HTTP request coming in. And then I use the recorder to catch what the handler ends up doing. And then I'm making an assertion at the bottom there to see that the status code was OK. And you could test error cases here too. You could pass in some invalid data and make sure that it's not an OK response, So you can start to use tests to describe the functionality of your server. And the other advantage of having good test coverage, of course, is you can deploy with confidence. So you don't have to worry about having very careful kind of release schedules and things like this. You can sort of release continuously, which is a very nice situation to be in. If the only promises you've made about your service are encoded in those tests, you know that you can deploy it if the tests pass. And actually, we often will just have anything that gets pushed into master. We use the continuous integration in the pull request, so it runs all the tests in the server. Then it gets merged into master, and then it gets deployed automatically. So that flow is very nice. And it's sort of, if you start doing that, it's kind of easy to keep going. It's quite difficult to retrofit tests into this. So that's why having testing and caring about testing from the very beginning is important. The other nice thing is we only have to set the dependencies that we need. So if this server had an email sender, but this endpoint doesn't use it, we just don't have to set it. It'll just be nil. Now, if we do decide to change the functionality, and we didn't update the test first, I would update the test first in that case and see it fail. But if you don't work like that, and you do add the email sender, running this test would then panic because that email sender's nil. And then you have to go and fix the test. So either way, it's more kind of compile time, or it's not compile time, but it's more help from the machines, which that's what they're for, isn't it? So now, remember, if you put the request and response types inside the handler environment, then one of the criticisms that was in that Reddit was, well, then you can't use those for testing. And that's true. But you often don't need to, and it's not worth it, I don't think. It's not worth having it cluttering up the package space just for that. And you can do things like this with a little anonymous struct. And I'm coding some JSON here, so you can see that I have this P, and it just has a name, and I set the name to my name, and then I encode that to JSON, and then I go on and do my test. So what that's doing there is making it very clear what this endpoint cares about. So it's got great glanceability and storytelling properties of it. This P there might be a person in this project that has a name, an address, a profile picture, number of something, number of arms, why not? Whatever it is, you might not need it in this case. So we have this greet endpoint. It doesn't care about all those other things. All it deals with is the name. And this makes that extremely clear. Now, you can test this server in a couple of ways. And you can think of them almost as integration tests versus unit tests. So in the top case here, I'm calling serve HTTP. And so that is testing everything on our server. It's going to go, remember, it's going to go to the router first. Then the router is going to decide which one gets called. Any middleware on that handler is going to run. All of it will run, including then hopefully the handler you're doing. And so you're really testing the entire stack in this little world, the entire stack, versus just directly calling that handler as a method. And if you call just the handler, it's literally just going to run only that piece. So this is a very nice way of isolating your tests, right? If there's a bug somewhere, the perfect case is a single test fails, because that's like a laser pointer to what's gone wrong. If something breaks and you only use the kind of integration thing, say something breaks in a middleware somewhere, all of your tests are going to fail, and then you still have the work to go and figure out what's gone wrong. So I always kind of prefer unit tests for that reason. It helps. And if you do want to stub out a third-party service, you can use the new server here with a little fake handler. And what this actually does is it binds to a random port and it's a real server that you can then make real HTTP requests to locally. So that's almost like a level above than the integration testing. You're not just testing just your stack. You're actually running real HTTP stuff. And that's very useful if you do want to stub out a third-party service. You just do it like this. So you can see that I create this SRV. I use http test.newServer, and I give it a handler. So that handler is what mimics the third-party thing. And then you just access the URL from the server to build up the URL you're going to hit. You have to do that because it gives it a random port, so you have to know where to go and get it. Very useful, turns out. Middleware are also testable in a kind of similar way. You create a dummy handler, and you then ask the middleware to wrap your dummy handler. And then if in this case all it's doing is increasing a counter, we just want to make sure it got called or it didn't get called, then you just do that in line. And it's kind of, again, all in one place. It's just a test function that has everything that you need for that case. Now, of course, if you find yourself doing this a lot, it might make sense to create a constructor for it for your test code. But as you can see, it's very clear, and you can see that my first test here is to see that it's not an admin, so I send an incorrect authorization header, and I check the counter stays at 0, then I make it valid, and I check the count as 1. And all I'm doing is testing the middleware. It's isolated, and it's laser pointer. So, that's it. Write boring code if you can. Use a server struct, hold your dependencies in there, and avoid global state, and avoid a whole array of a whole slice of other errors. That was definitely sarcastic, that laugh. Your routing in one place means you get a nice map of the entire service. Very useful for debugging and maintaining. And I use anonymous functions instead of actually having the handlers there directly to create that closed environment, and you can do interesting things within that. And, I use the HTTP package, HTTP test for testing. There are some other frameworks and things out there that you might like, so check them out if you want. And you can also read this on the blog. And I just want to say a quick thank you for coming. Thank you to the organizers. These conferences are not easy. I mean, just look at it. It's not easy. It's a lot of work, and I don't even know how much work goes into it because I don't help. But it's a lot of work, even from what I see. So, and the other thing is, thank you to everyone that's helping make this community so diverse. It really is important, and if it wasn't a diverse community, I probably wouldn't be involved in it, to be honest. So I came for the go, but I stay for all this diversity, these interesting and different and strange and weird. So, thank you very much.